Welcome back. In this session, we'll explore how Retrieval-Augmented Generation, or RAG, stacks up against traditional generative models. Understanding these differences is crucial to appreciate why RAG is gaining so much attention in AI-driven applications. By the end of this talk, you'll clearly see how RAG addresses the key limitations of traditional models and unlocks new possibilities for AI systems. Let's get started. Traditional generative models overview. First, let's quickly revisit how traditional generative models work. Models like GPT-3 or GPT-4 are trained on massive datasets, learning the patterns and structures of language. They generate text by predicting the next word in a sequence based on the input they receive. While these models are incredibly fluent and versatile, their knowledge is fixed at the time of training. Once the training process is complete, they cannot acquire new information unless retrained. This means that traditional generative models are essentially static, and their understanding of the world gradually becomes outdated as time passes. Moreover, these models operate purely on the data they were exposed to during training. If the training dataset lacked information on specific topics or recent events, the model won't have the knowledge to address queries related to them. This can lead to inaccurate or fabricated responses, a phenomenon known as hallucination. How RAG differs. Now let's introduce Retrieval-Augmented Generation. The key differentiator of RAG lies in its ability to dynamically retrieve information during the generation process. Instead of relying solely on pre-trained data, RAG models pull